Now let's take a look at using the ultrasonic sensor to avoid an object. And the goal of this video is to look at how we can start using sensors to influence the locomotion of the robot. So we're actually going to have a program that encompasses movement and also feedback from the sensors. So let's set up a little task for ourselves. So what we're going to do is we're going to write a program that will have our task bot continually move forward and all the while looking for an obstacle. If it ever detects an obstacle, what it's going to do is it is going to back up, turn to the right, move forward, turn to the left, and then continue going forward. And notice that I draw the red as what the activities will be when you detect something, and then the blue represents what you do when you don't detect. That means that we can put this in a loop, and once you get over to this part, you can just continue back in your main loop, moving forward, looking for an obstacle. Okay? Alright, so that is going to be our task, and again the rationale for this is just to learn how to use both locomotion and sensors in one program. So go ahead and fire up your Lego Mindstorm NXT software, and what we're going to do is let's go ahead. I have my task bot here and I've got some obstacles set up, so I have some flat surface books, and those are what we're going to avoid. So I'm going to go ahead and start a new little program called avoid 1, and I will say go. And what I want to do is I come down here and I notice that there's these little tabs, and they allow me to switch between the complete palette, which is what we've been using, and over here is the custom or the common palette. So the common palette is a little more useful because it has all of our moves and our switches and loops in there in an easy to reach location. So I'm going to go ahead and start with the loop, because we know we're going to be continually in a loop forever. And then I'm going to put a switch in here, and the switch is how we are going to control the ultrasonic sensor. So let's go ahead and set up the sensor. I come down and I want to go to ultrasonic sensor, and notice that the number shows up right here, so I go ahead and switch that to port 1, which is where we have it connected, and it changes to port 1. Then we're going to change it to, let's look for obstacles that are within 3 inches, and what this means here is the little flower means things are close, and then mountains mean they're far away. Okay, so that means that when we see something close, when we see the object, we're going to go down this path, and then when it's far, we're going to go this way. Okay, so let's go ahead and take a look at what we should do when we are not detecting an object. So I'm going to come in here and I'm going to set this up, and when I look at my task bot, I need to verify that the motors are on. We haven't really paid too much attention to it because we haven't been really being precise in our in our programs. I'm going to make sure that I've got B on the right and I've got C on the left, and so that means that when I draw these out and I'm trying to turn, I can actually say, okay, I'm going to turn left and turn right. So this is actually how we connected this originally. So we're going to move forward, and I want to do it, let's go 50%, and I want to just show you something that's kind of interesting when you first start this. We have been doing motion in terms of like 1 rotation 1 second, and I'm going to put it at 1 second, and if I hit play on this, what it's going to do is it'll come through here, but it will only move for 1 second, and while it's moving for 1 second, it will not be looking for an obstacle, so it will not be using the ultrasonic sensor. So that's a limitation, because when it comes out of this loop and comes back to make the decision on whether some things are there or not, if the obstacle just happened to appear in the second when you were moving, you might actually run into it before you can detect. Okay, so let's take a look at what we'll do there. What I want to do is I want to go ahead and let's put a sound in this path that it'll take if it doesn't see something, and I also want to control the motion when I see something, or this is the path when you see something. So what I'm going to do is I'm going to take this motion block, I'm going to go ahead and copy and paste it, and I'm going to pop it in here, and I'm going to put a stop on here. So this is the stop command. So what I'm going to do is when I see something, I'm going to stop, play a tone, and let's go ahead and set the tone to something low like that, and play it for, let's play it for a second also. And then what we can do is then it will come out of that, it'll come back and say if there's nothing there, it'll move forward in 1 second increments. And let's just test this out right now and take a look. So I'm going to go ahead and download this to my taskbot. And I use the download because I have motion in here and I don't want it to take off on me. So I'll go ahead and run this program, and there it goes. Notice that it's really jerking along there. It's really jerking along. Okay, and then it decided to see something. And the big problem with this is that if it's moving along, so that it just happened to see it. It was in the little split second in between the 1 second moves that the obstacle was detected, but it doesn't always see it. Sometimes it might happen where if it runs into the obstacle, or if it's moving while the obstacle appears very closely, it'll actually just run into it and you won't be able to see it. So to fix that, what you can do is you can do one of two things. You can either try to make this movement block very, very small, so like 001, but it's still going to be real jerky. But you can actually use the unlimited setting of this. So you can come into the motor and you can set it to be unlimited, and that means it'll go almost instantaneously. It's moving and instantaneously checking, moving and instantaneously checking. So let's see if this is actually going to be a little bit better. So we go in here and I download my program now, and I'm going to go ahead and I set my wobble wheel so that it's back so it won't do anything, and I go ahead and move. Notice how smooth it is now, and then it sees the obstacle. It's just going to sit there. You can hear it clicking because that's the 1 second interval of the tone, but it's able to see the obstacle and we're off and running, and it's very smooth. So we want to use the unlimited setting when we're doing the detection. Okay, great. So now let's do the let's go ahead and I want to leave the tone in here. I'm gonna stop, and then I'm gonna play the tone, and we'll play it for that amount of time. And then what I want to do is I want to back up, and let's do two types of turns. Let's do one where you back up and turn to the left, and then we'll move forward, and then we'll turn, or excuse me, we'll turn back into the left. So we'll go like this. We'll turn back into the left, and then we'll go forward, and then we'll go forward left. Okay, so this is the equivalent of coming back, turning right. Instead of actually going forward and turning right, we're going to back up and turn to the left, just to show two different types of turns. Okay, so I'm going to go ahead and copy and paste my block for a move block. So this is going to be my back and to the left one. And this one, I'm going to go back and I'm going to go to the left. Okay, and we don't want to do this unlimited at this point. We want to do this as seconds. So let's go ahead and do it for, I don't know, let's try 1.5 seconds. And that should back up and go to the left. Then I want to go forward. And so I'm going to copy my forward move block again. And this time again, I don't want to go unlimited. I want to go for seconds. So let's go forward for 1 second. And then finally, let's go ahead and turn to the left. And if you ever get off screen, your workspace gets off center, you just hit home. And okay, so I've got this is going to be my forward and to the left. So I should be able to go forward and to the left. And I don't know, 1 second. Let's just try 1 second. And then that's it. Now I should be pointing about roughly where I want to go. So now I have the general flow of the program that I want to do. And now what I want to do is test it. And then I can dial in all of the settings that would actually make it be a little bit more accurate. So let me set up my obstacle again. And let's really monitor what's happening as I move through these motions. Okay, so I'm going to run my program. It's moving forward. Obstacle back and to the left. It didn't go very far at all, and then it turned left. Okay, so it worked. It did what we told it to do. We didn't tell it to do enough. So here is where we are backing up, and we wanted to go back into the left. I'm going to make it go back into the left a little bit harder, and I'm going to give it a little bit more power, because one of the things when you do that skid steer, which is where your one wheel is moving faster than the other, one wheel is moving really, really slow. And these servo motors, when you set the power level to something really, really slow, it doesn't scale linearly. Like, they almost go dead when you put them too low. So I'm going to give it a little bit more power and a little bit more of a turn, and then I'll give it a little bit more that should give me a pretty good turn. Then let's go ahead and we're going to go forward for that, and then our left-hand turn didn't work hardly at all either, so let's go ahead and make that 75, and let's see if we can put that at 1.5 seconds too. Okay, so that's dialing in pretty close to, or we're at least dialing into something that should be closer to working. All right, so again, I always try to set my wobble wheel so that it's in the forward location, because otherwise it'll start off in the wrong direction, or it'll start off with a turn. Okay, so here we go. We have a object back off the table almost. let's do this. Let's run this one more time and make it so that it doesn't go off the desk there. So Let's just see what happens here. So there it goes. Obstacle. Back into the left. That was perfect. Forward right. Forward left. And then it's forward again. Okay, so this is almost perfect. The only thing left to do would be that last right-hand turn just wasn't quite enough. So let's go ahead and make that 2 seconds. And then this should be it. Now you can see right away why you do this on the floor, because you have to really dial in exactly the durations of time so that it doesn't fall off. But it's exciting. So let's go ahead and run this. All right, here we go. Obstacle number 1. Seize it, back into the left, forward, to the left. Now it's going again. Okay, so this worked pretty good. This worked pretty good. I'm going to do, let's see if we can actually detect a couple different objects. So let's see if it, line it up so it sees that surface. Okay, so here it goes. Seize it, back into the left, forward, to the left again. Now it's going to go, seize an object, actually hit it this time, backs up, goes around, and it's off and running. So we just did it. We have now created a program which can detect and avoid an obstacle. Okay, so why did we do that? The whole reason was to start putting together more and more sophisticated programs and to try to use sensors to bring a more intelligent decision back into our program. And that allows our robot to not only have locomotion, but to influence the locomotion based upon the environment that it's in. So that's going to earn you 3 really small checks. And you might think that that is equivalent to 1 big check, but it turns out that's not, because we still have one more sensor. We have the light sensor, and we want to look at how to use the light sensor also. So we've looked at this point using the ultrasonic sensor, but we also have a light sensor, and we want to kind of look at the theory of that, because then once we have that final sensor, we can bring it all together and actually build what we call autonomous programs, which are very self-contained, self-aware programs that the robot can perform.